Last Friday, we showed you the production design intent vehicle, Delta. Now we're moving swiftly into production, and we'd like to show you what the engineering team has been doing to get us there.
It's really been because of your support, your investment, that we've come so far over the last year. And our engineering team has done some truly amazing work in that time. We want to show you how we've used your investment and talk about how you can help us take our next steps into production. This presentation is very confidential. It's really us sharing super confidential information with you because you've supported us all this time. But it's good stuff. It's juicy stuff. So let's go through this material, and we'll bring in Akosh and Nick over time to talk about how all this is coming together. But really, you guys all know our mission. We're a creative company. We're creating energy for transportation and doing it in the most efficient manner possible. And we've got an amazing team together to do that. Sarah and her team have done such an amazing job putting all this together on the marketing side. And Pablo's done an amazing job on the manufacturing side, taking everything that our engineers have created and figuring out how to actually build that with the help of Sandy Monroe. We'll also talk about our partners and how all those people have come together to help us. We'll start the presentation talking about industrial design. Jason's not here today. We wish he was, but
He's watching.
He hopefully watching, at least on the at least on the link. But he really took our mathematical shape and made it beautiful.
Right. We gave him this, like you said, mathematical shape, and said fit two people in it side by side and make it look nice. Because the shape of zero drag is one thing, but making it into a passenger vehicle that people love is entirely another.
We think he's come up with something beautiful, but here's what it looks like in its raw form without any of the covers on it or coloring. And we think that what we've ended up with is just striking and beautiful, and certainly will get noticed in your community. When you bring your first Aptera home and park it in your driveway, be prepared to answer your door, because people will come knocking, asking you what this amazing vehicle is, and you get to tell the wonderful story about solar mobility.
Not for introverts.
Not for introverts. But this is our launch edition vehicle. This is the latest renderings from Jason. The beautiful interior, I think, just says so much about how we're trying to make this vehicle not only the most efficient thing on the road, but also comfortable and very usable.
Just one thing, you're going to see some real hardware today too, but what's important about these renderings is they are from CAD data. This is the same CAD data from which the interior tooling, the body tooling, suspension tooling, everything is made from. It's taken from CAD data and then rendered. So it's not just something that's drawn, it's actually production CAD data that you're looking at that's been rendered into a nice image.
Yeah, it's been very cool to see the engineering evolution through each kind of cycle of our existence. We had the alphas, then we had the betas, and now gammas out in the wild. It's in Italy and now traveling to Switzerland. But we design something in CAD, and then we actually build it, and you get to see it come to life. And that will be the same thing with this vehicle as you start to see pre-production vehicles soon.
Now we'd like to welcome our Vice President of Engineering, Akosh Feher. Akosh, good morning.
Good morning. Nice cozy couch.
Yeah.
Thank you.
It's a love seat.
Thanks.
We'll get close and cozy. But I started talking to you maybe 2 years ago, and then we brought you on the team about a year ago. It's been a pleasure working with you and bringing all your previous skills to the table, especially
Likewise.
in high volume composite manufacturing.
We had this problem of Chris and I thinking that we would only be worried about making 2,000 or 3,000 vehicles a year. And when we turned on the pre-order program, we got 2,000 reservations in the first week or two. So we realized right away that our old way of thinking about composites and resin fusion and stuff, while great for low volume, just wouldn't scale to the demand that you folks were showing us. I think now we're almost at 41,000 reservations. So we said we've got to find a better way to make this, lower cost, faster, higher quality, 20, 40,000 units a year. And that's where Akosh comes into the picture. So he found the perfect partner for us.
Yes. So when I came on board, the mandate was very clear: 20,000 vehicles a year. We couldn't do it the way, as you said, we couldn't do it the way that we were planning on. Originally, we needed new technologies, new ways of looking at the problem. We also had to maintain our ability to create a safe vehicle. for our clients and customers. And also at the same time, when you look at 20,000 vehicles a year, that translates to 10 to 12 minutes to build one vehicle. And that requires a completely different skill set and technologies. We have an amazing team here in Carlsbad, but we knew from the beginning we couldn't do it from just by ourselves. So we actually had to bring on board some key partners that would help us build this.
You built a global team of vendors and suppliers specifically for this. So maybe you could tell us a little bit.
Well, really, the impetus for this team was our shift from cord composite structures into carbon fiber SMC, and that kind of drastically changed the vehicle architecture. So you had to kind of build a new team to focus on how do we build with this new technology, this carbon fiber SMC that is great, strong, lightweight. You can embed fasteners and posts to connect things to. It really is a game-changing technology to build 50 or 100,000 vehicles a year, not the 2,000 or 4,000 vehicles a year we could build with resin infusion and cord composites. But I really saw this as you kind of reshaping the company around this new carbon fiber SMC and how we execute on that in high volume.
Yes, and we were lucky to find this new technology and a company called the CPC out of Modena, Italy. They are in the heart of the Motor Valley in Italy, and they have this technology that the easiest way to describe it is like a waffle iron, stamping composite panels. And later on in the presentation, you will see how that actually allowed us to create a very simple architecture for the vehicle. And it wasn't just my merit to bring these partners. Obviously, Pablo's team has done an excellent job in building a global team of partners around this team here in Carlsbad. And on the slide, you can see some of the key partners that we have. Obviously, CPC in Modena and ETP. I guess Italians love acronyms for names. So ETP is a highly regarded engineering design firm in Turin, Italy, that has been working with CPC for decades, and they have been instrumental in helping Jason translate the design, the industrial design, into actual CAD, engineering CAD and parts. And the next step is going to be obviously tooling, and I know you will show some goodies about that later. We also have companies like Danesi and Steparava and Costem. They are working on the structural battery frame. And from the beginning, we have been working with companies like Roush and Yazaki, and obviously Sandy Monroe's team up in Detroit. So again, we have a very focused, very hardcore team here in Carlsbad, but working globally with these partners that without these partners, we wouldn't be where we are today.
One thing about the Motor Valley in Italy is that our volumes, let's say between 20 or 40,000 units a year, they seem like a lot for us. But if you're talking with any kind of tier one or automotive company in Detroit, that's nothing. They might not even accept the meeting or return your phone call. Yeah. But that 20 to 40,000 unit per year is the sweet spot for these companies in Italy. And you couple that with a strong dollar, versus a euro, and we're really able to stretch our dollar in terms of engineering effort, output, value, by working with these companies that you brought us from Italy.
And one of the big surprises for us, positive surprises for us, was the enthusiasm that not just CPC but ETP and the rest of the partners have shown. They are not just suppliers to us; they literally bought into the project, and they want to be partners, and that was great to see. And again, we know a lot of companies that know how to build 1 million of something. We know a lot of companies that know how to build one of something. We are kind of in that middle, that very challenging middle. And I think we're on the right path to actually crack that nut and really make it work around 20,000, 30,000 units a year.
Now we wanted to take you through kind of each of these zones that we call them, engineering groups, and show you their amazing progress.
So Anuj Thakur is our head of solar, and he was our first employee that we hired for the solar project. And he basically was given an empty room, the ability to hire a bunch of employees, and a ramp card with a virtually unlimited amount of spend to figure out how do you make automotive grade panels that you can bend in 3 dimensions. And since then, he and his group have created the single largest, I'd say, contingent of intellectual property within the company, all about making these solar panels, making them, bending them 3 dimensions, figuring out how they'll last for 10 years, from UV protection, from hail protection, impact protection, vibration like you'd have in automotive. There's nobody really doing this at the time, and so we had to figure this all out from scratch. But in doing so, we believe that we have the highest performance solar panels, lightest weight solar panels, probably going to be the lowest cost solar panels for automotive use. One of the things that makes these panels unique is their ability to have high longevity, so over 10 years, to be very lightweight, and that comes through the proprietary stack of materials, not only the composition of the polymers, but where they are in the stack and how thick they are. That enables us to protect against moisture and all kinds of other contaminants over a long period of time. This is a really cool picture here. Most people don't know that if you reverse bias a solar cell, it'll emit infrared light. And so this is how we test for damage during our impact tests. On the left, you see, for example, an off-the-shelf stack of laminate. So that if you buy a solar panel from Amazon or something like that, you would have a laminate stack that's very low cost and easy to make, but it's not necessarily designed for longevity. So, we can test panels like that against, or that stack, I should say, against our panels with our hail gun that Anuj and his team have built. I don't know what it is with the Americans' fascinations with building guns, but we built an ice gun to shoot the sort of regulation 1-inch ice cubes at this panel. And you can see that on the left, the conventional kind of way of doing it, these cells don't illuminate, means they're not functioning. But on the right, our cells still continue to illuminate, which means there is no cracking, micro cracking, or anything like that. So, being able to model the micro cracking, track it, make sure that it's not propagating is just one of the many small things that Anuj and his team have done to make sure these are going to have a long life.
Anuj has been doing a great job building out the assembly line in the solar building, and he's actually at low volume production now, but we're aspiring to fill his facility with solar production equipment and really ramp that line up.
Yeah, and this is a line that Anuj and his team have designed and also had feedback from Monroe and Associates. So, these are world-class people, not only looking and reviewing at this line, but just making sure that it's going to meet all of our requirements so we can build all the vehicles that you've ordered.
And let's not forget about the challenge that they had to integrate these solar panels with our new Bink. That is something that we actually pretty much on the forefront of technology. Nobody has done that before, so it's a great challenge. But I think we are doing really well and making sure that these panels integrate very well onto the body of the vehicle.
Gustavo has been leading our amazing structural battery pack team, making one of the industry's most energy-dense battery packs. It's been great to see the evolution over the last year, working with Sandy's team, analyzing other people's battery packs that are in production, and taking all the good and adding in some of our proprietary technologies to really make this a super energy-dense pack that really works well for our 42 kilowatt launch edition vehicles. These are just some renderings of how the pack kind of comes together.
Some of the different layers that you're looking at are the cooling plates on the individual modules. So a lot of the speculation in the forums and online chatter have been, is the battery air cooled or not? No, the battery is liquid. It's liquid cooled, liquid heated. So the thermal management of the battery is liquid. Whether it's heated or cooled depends on the environment, but it is a liquid cooled battery.
Carl's been doing an amazing job leading our powertrain team, working with Alafe to co-develop more energy efficient, lighter weight, less part count propulsion device. And this really is the most efficient powertrain you can put on a vehicle now.
Yeah, if you look at it might be difficult to see the power curve, but the standard motor that Alafe had developed was very efficient in a regime that was not our regime. So it was very efficient under a higher load that you'd need for a heavy vehicle. Well, with the Aptera being so lightweight and also not having virtually no drag resistance at speed, it was in a different load regime compared to what they designed for. So we had to shift the design of the motor, change the windings, change the arrangement of the magnets to shift that sort of efficiency mode from where it was to where Aptera will dwell at high speeds, and that improved the efficiency tremendously.
This is kind of the motor breakout, but I think it's significant to point out that the upright, the thing that holds the motor to the suspension, is actually part of the motor. So we were able to reduce part count and reduce weight, and it's just a much easier assembly to put together.
All right, to be clear, this is not their motor. This is the one that we co-developed.
Yeah. We also co-developed a silicon carbide inverter with a partner just north of us, and it's great to have an inverter that's 97% efficient versus kind of the industry 92% efficient. You can take that extra efficiency, that 5% extra efficiency, and take that right out of the battery pack because you're not losing those electrons as they're going through the inverter to the motor. You don't have to have the battery power to push those electrons. So the money we save on battery, we can spend on a more sophisticated inverter.
Yeah, and this is a Rev A inverter. Rev B, the package is, I'd say, significantly smaller. So we're not showing a rendering of that yet, but we have to leave something for a surprise. But the silicon carbide makes that efficiency possible.
Vidar has been doing amazing things in vehicle integration, mostly on the low voltage side. This shows you kind of our low voltage harnessing.
Yeah, Aptera has taken what we call a zonal approach for low voltage I/O. That means instead of having a traditional big, unwieldy copper wiring harness that goes over the whole vehicle that weighs hundreds of pounds, we have actually a very small harness that connects point of use controllers around the vehicle. And it connects with a LIN bus instead of a CAN bus. And the reason why that's important is you hear of CAN bus in automotive, it's kind of the standard. And our systems use a CAN bus for powertrain and infotainment and things like that. But when you press a button and have the window go down or open the trunk or do anything like that, that doesn't require the high-speed nature of CAN. So we can use LIN. And the reason why that's important is it means the chips are cheaper, they're more available. And it makes the overall cost of the wiring system less than if it were all CAN based. But it's distributed, it uses less copper, it's lighter weight, and it gives us virtually infinite control.
Yeah, 30-pound wiring harness versus a 90-pound wiring harness.
Right.
And this shows, this is a great example of the modular approach that we have to the whole entire vehicle. Mm-hmm. This approach allows us to really integrate all of the systems, not just the electrical system, with the BINC and the structural battery frame.
And I can't leave out that Vidar is also on charging systems, and he was the one who integrated the new NACS Tesla charger into the vehicle.
Yes.
So
thanks, Vidar.
Great progress.
And he made us famous in Sweden.
Exactly, he's Swedish, so the Swedes love us.
Tack så mycket.
Charlie is leading our body controls and electrical engineering, and really leading the team that controls the zonal architecture.
Yeah, so just to elaborate a little bit about this, you might imagine a single wiring harness. Why would you even think about this? Why would this be an area of focus for us? Even with modern OEMs, one of the biggest problems for warranty and repairs are wiring harnesses, the connectors. And so simply by reducing the size of the wiring harness, reducing the number of connectors and connections, you can increase quality and reliability by moving all that to silicon, to circuit boards. And so instead of wiring harness that goes everywhere, we have a very small harness that connects these point of use controllers, POUCs that we call. And the POUC has a common architecture, hardware and firmware stack that we developed that's the same for every one of them. It's abstracted. So it's only the small IOs, whether it's digital inputs or outputs or analog inputs or outputs, that change based on the specific need. But it's all connected with LIN bus. It's much cheaper than CAN bus, and it's lighter weight because instead of 4 wires, we only need 3.
And this actually shows all the things that those point of use controllers control. So there's lots of things in the vehicle, even though we're a very simple vehicle, but you still have to turn on the lights, you still have to run the air conditioning, you still have to do all those those things.
The pumps, the vanes in the air conditioning unit to direct the flow, any door sensor, all those things have to be read by something. In a traditional automotive application, they're all routed back to a central box. That's a lot of wiring, a lot of copper. We push it out to the extremities, to the point of use where it's used, and we save on the copper and the cost.
Brian's leading our center infotainment display division, human-machine interfaces. We actually acquired his company, Andromeda, and they had developed display systems, and we're selling them out into the EV world to different commercial applications and agriculture type vehicles. But we've really taken what he's done and taken it to the next level. Our energy tipster that shows you how far you can travel, not just in a bubble, which most people do, draw a circle around you, but actually when it comes to traffic, climate, and elevation. So this map on the right here is how far you can go on the charge in your Aptera per the streets and per the elevation. So not just a bubble of, hey, you have 200 miles of range, but this is how far you can go on that road. And it's a really cool system, making everything very usable for the Aptera driver, knowing how much energy you're using, how much energy you're creating, and how far it will take you is kind of the goal with our display systems.
So Nathan Engler is heading up our chassis and suspension team, and this team is responsible for developing the chassis and obviously our suspension system, and also going to morph into this new role of leading our validation, homologation, and testing team in the next few months.
That's a really interesting point. Maybe a different company or a larger company would have a chassis team that's constantly creating new chassis for new vehicles. We're laser focused on this vehicle right now. So he's able to take his team, because they have done this kind of validation work in the past, and transform them into the validation and testing team.
Absolutely, and this is a good rendering of the current status of the structural battery frame that is very modular in nature, and obviously it was a departure from your original idea of using a front end and the rear end structures, sandwiching a composite body.
Which we fought.
Yeah, the beta that people have seen actually has a front suspension and a rear suspension that's attached just to the composite body, and there wasn't really a force vector from the front suspension to the rear suspension except through the body. So I think one of the big things that happened when we started talking with CPC and ETP is they said create a load path from the front suspension to the rear, and everything gets a lot easier.
Yes, and we will see that in the next few slides. But this architecture also allows us again to go back to the famous 12 minutes cycle time. We can build this frame with the suspension components on a sub-assembly line, and then marry it with the bink at a later point in the assembly line. This is the front end of the vehicle, again very modular. It's an unequal A-arm setup. We brought the shocks and suspension components to the center of the vehicle, centralizing the center of gravity into the nose of the vehicle. And again, as we said, it's a modular setup. So I think Sandy Monroe is in love with the idea of creating sub-assembly lines where you can put components together. This whole front end can be put together in one station, and then installed into the frame and then into the vehicle at a later time. And we can allows us to play with the location of the assembly lines.
Right. When this subassembly is presented to the line doesn't care if it's made in whatever state or whatever country even. So that gives us the flexibility to make these wherever it makes sense.
Yep.
But then it's just a simple attachment to the vehicle.
And that fits really well into Pablo's plan of world domination. He really wants to build Apteras in every corner of the world, and this type of approach allows us to do that. It also reduces the costs and the risks, and later on quality problems.
Eight bolts and a couple of connectors, and you got a front suspension.
Exactly. So this is the rear suspension architecture. I think you guys started out with a single-sided swing arm, kind of like a motorcycle style, and then that had some problems and created
all the-
some problems, and now we ended up with the 4-link rear suspension that we have that works out really well.
All the other three-wheelers out there have single-sided swing arms. The problem is that as that swing arm moves in the rear, the tire actually gets closer and further away from the front suspension as you accelerate and decelerate, and it gives you some interesting, odd suspension characteristics that you kind of feel when you're driving. But this 4-link suspension lets the rear wheel float very predictably up and down evenly with the front suspension, so you don't feel it when you're stopping or accelerating. It feels just like any other kind of 4-wheel vehicle you drive.
Yeah, the single-sided swing arm or a long swing arm works really well for a motorcycle that has a different geometry, different CG than we do. This setup is ideal for our architecture.
And patented.
Patented, yes. As we said earlier, and we will show you in a little bit, actually next slide, we have done a lot of computer analysis on the structure, to increase the level of safety and also to predict how the vehicle is going to behave once we are in production. And that this type of analysis allows us to not only to make it safer, but also speed up the development process. The switching to the structural battery frame idea architecture allows us to drive the forces, the energy in an impact, like a frontal impact or a side impact, corner impact, underneath the drivers and the passenger instead of into the actual structure. Not only makes it safer, it also makes it easier to repair, easier to service later on in the field.
And even though you get increased vehicle torsional rigidity from the structural battery pack, it still allows the impact forces to go past the battery pack.
Yeah.
Yes.
Important to note that the heaviest mass item of the vehicle is the battery, right? So try to put all the impact loads into the highest mass item, and that's exactly what this does. So I love it.
And the other thing is these obviously modern tools that allow us to analyze it. We know how aluminum works, so it's makes it very, very predictable, and reduces the risk of tooling something up. So we can eliminate some intermediate steps in the development of this whole entire project because we can predict how these components are going to behave.
That's a really good point. The earlier sandwich core composites we were working with, while very fast and low cost, the discontinuities between the foam core, the resin, and the skin, they're difficult to model. And so typically the only way you can characterize them is through destructive testing. But this SMC material from CPC, along with the aluminum, both which are well understood in their behavior, they can be modeled perfectly, so we don't have to do destructive testing. We can have high degree of confidence of the simulation versus real world testing.
And a lot of things that we do in digital, then we also test in an empirical manner, so out in the field. And again, going back onto Nathan's team, chassis and suspension, this is what they do, and they will be continuing doing, taking the digital data and predictions and make sure that the real world behaves exactly the same way as in the computer.
Yeah, the previous frame analysis was really finite element analysis, how that material changes on impact and under stress. But we also have simulations on how the vehicle moves and what the kinematics are of the vehicle. And that helps us with analyzing things like how will the vehicle react in curb strikes, and how will the vehicle react, on pothole tests, and, swaying back and forth and things like that. So we actually take this as beta, instrument it up, put a lot of computers and sensors on it, and then go out and test how the vehicle actually performs in the world, so we can correlate that data to what happened in the simulation. And if you get really good correlation, then when you make a change in the future, you know that change is going to work in a predictable manner.
Yeah, and the curb strikes are pretty violent. I mean, it busted
Yeah.
all 3 tires, I think. Didn't just deflate them, it busted them. But it allowed us to collect the data to then put into the Adams model, so that we have a very high degree of concordance between real life and the Adams model. So like you said, we can make a small change in software and have a high degree of confidence that it's going to behave that way in real world.
And this chart shows the red line is the simulation, and the blue lines are when we actually went out and got real world data. So we had 95% correlation, which is just amazing, and shows you how far the simulation tools have come. This is our suspension test jig. Our engineers were considering what wires to use to go to the in-wheel motor out on the wheel and what cooling tubes to use and how they would stand up over time. And the only way to really understand it is to test it. So this guy's been running for a couple months and already has 200,000 plus miles of durability on it. But it goes up and down and it turns the wheel and it shows you how those cables and hoses are going to rub over time.
And it was really helpful because a lot of our assumptions about how to fix the cables and hoses or not to, how they would be captured or allowed to slide. Some of those concepts were jettisoned and some of those were reaffirmed. And so we were able to learn that early on with this and have a high degree of confidence so we can get, many, many miles durability out of those systems.
This is a good example of some of the areas that there's no historical data for it. So there's nobody out there doing the same thing, so we couldn't just go back and say, hey, what did some other OEM do in this situation? This is our own unique setup, and we are learning as we are doing it. So
it's a good point.
It works very, very well. And all this chassis work underlays the new body structure.
Yes, so going back to full circle, so this is the architecture that we've been talking about since the beginning. This is what CPC is doing for us. The renderings that you saw at the beginning of the presentation were actually based on the CAD data that you see here. The key is we have 6 main components to the BINC.
Compared to what?
Compared to a magnitude larger number that you would have in even a simple passenger vehicle made out of mostly sheet metal. And the tooling compared to a regular passenger car is also magnitude cheaper and simpler. And the way that the 6 components come together, it's like a Lego. It just snaps together. It makes the assembly line very efficient and streamlined. We need a fewer amount of robots and technology, and no welding, which is also good for CO2 emissions. And one of the key aspects of carbon SMC and glass SMC is that they are highly recyclable.
Yeah.
There are new technologies out there where they can reclaim the actual fibers and also the resin from these components and reuse them 5 or 6 times for the same type of application. So not just our vehicle is going to be very CO2 emission centric, but also the actual supply chain and the actual manufacturing methods going down to the raw materials. Actually, CPC mixes the raw materials right next door to their stamping facility, so there is no need for refrigeration, there is no need for transportation for these materials. Again, we have looked at the full life cycle of the product, and that's what gave us this very simple and very elegant BINC architecture.
And this is something that we also could not do with our previous method of composites. Yeah. So we're really pleased that this material is recyclable, reusable, and that's just a story that we couldn't tell before.
And one of the main things that brought you guys initially to composites, and also has been one of our mandate for the last few months, is safety. I know in different markets we are going to be homologated differently. Here in North America, some of the rules that apply to us are for motorcycles. But we as a company really wanted to make sure that we are meeting the same level of safety as a regular passenger vehicle. So we are testing and designing and engineering this vehicle to the FMVSS, so the Federal Motor Vehicle Safety Standards that are required for a passenger vehicle. And the BINC, the architecture that we have, allows us to meet those levels of safety. So all of us can sleep at night that the vehicle is as structurally safe and sound as any other four-wheeled vehicle out there.
And the advantage, I guess, of making a larger car or something, it's just easy to add more steel.
Yeah.
But it's been extremely challenging to meet these requirements while also keeping the weight down. And you and your team have been doing an extraordinary job. But it hasn't been easy. There's lots of late nights, and just really putting on your thinking cap to solve very unique problems to give this level of safety, but with our weight requirements.
Yes.
Here we saw great results from the frontal impact, and now this is the roof crush on this slide, and then the side impact on this slide.
Yeah, so we are going down to into the details on testing everything and predicting everything, how to work in real life. One of the key aspects we are in such an accelerated development path that this type of technology allows us to be on, that we're going straight to production tooling, and I know you will be talking about that a little bit later. And this type of testing and this type of analysis gives us the confidence that we're on the right path.
Mm-hmm. We also have to test things like the hinges and door latches. When the wind catches your door, you don't want it to break the hinge. If somebody too aggressively opens up something, or the kid is riding his skateboard at 20 miles an hour and runs into your door, you don't want anything to fail. So we've done a lot of testing on the hinges and cycle testing, and it's all come back very, very well.
Just to make sure that it works in real life.
Yeah.
Again, the structural testing is not just for crash, but also for how you push on certain panels and how the whole body behaves. And one of the things we forgot to mention when we were talking about the solar panels, the way that the solar panels integrate with the carbon composite, the carbon SMC panels, is actually a novel idea. Instead of having two different layers of sheet metal, we have one layer of carbon SMC, and then the solar panel is actually structural. And all of those use cases have been tested digitally.
Structural solar panel.
Structural solar.
Your engineering team's doing amazing work. Now we wanted to talk about supply chain and production. And Pablo's not here, but we have Nick from our MES team.
So I'm off the hook now?
You're off the hook.
All right. Thank you.
Thanks, Edward.
Hey guys,
Hey, Nick.
how's it going?
Not bad. How about yourself?
Good. Thanks for inviting me on your morning show here.
Nick's been with us for over a year now, and he has great production experience with a lot of super interesting San Diego companies. And we brought him on board to help program manage, and now you're managing MES and helping the supply chain guys and doing all kinds of fun stuff for us.
We didn't talk about how your basketball game went last night.
We don't
Do
want
we
to talk
have
about
to?
that.
Okay. All right.
Yeah. I think I've been with you guys since you guys restarted this thing. Roles have changed over time, and now I get to work on our manufacturing systems, all the production systems as well. So roles have grown a lot. It's a lot of behind the scenes stuff. The vehicle's a very interesting part. Everyone's really excited about it, but sort of in the background, you have to get all the tools and systems and processes in place to be ready for the product when it's ready to go into production. So
What I've seen, sorry, go ahead.
Really, your production team has been working on this beautiful facility we're in now to get it ready for production.
And what I've seen at some other startups that I've either been involved with or made aware of is that, when engineers have a product that they bring to production, oftentimes things like the bill of materials are on a spreadsheet, and all the work instructions might be created and live somewhere else, and the documents and the CAD files are not all integrated. And then when the orders come in and it's time to scale, everything just explodes. So instead of doing that, Nick and Pablo started from the beginning to build the infrastructure in place so that we could have an MES system that lets us start and then grow and scale with as little difficulty as possible.
yeah,
Yeah, our MES system is Manufacturing Execution System. Not everybody knows those acronyms out there, but it's really to control everything. And you see the facility here. We have 12 stations that are building vehicles every 12 minutes. How does inventory move into that? How do you track, the torque of each bolt that somebody puts in? How do you track, when an operator takes a part off the shelf and now it's in the vehicle, so another part has to come from inventory. But that's what Nick's been working on behind the scenes, is really refining that system over the last year.
Yeah. We did a phased approach really to incorporate this. So that's what you see here, and it tied really well to the buildings, the locations we were in. So sort of different rules for different locations as we matured from making concept cars, show cars, the alphas to the betas. So we were at the yard there. We moved to what we were calling the Loker building, and now we're here at El Camino. And the design tools, we've been using the same design tools, but sort of adding more maturity as we go, moving from just tracking things on spreadsheets and using local vendors, machine shops, doing internal processes, to adding more engineering rigor, change control, revision control management, more documentation. That's where we started to test out our MES system, which really connects tools on the factory floor with your system and your demand planning system. And then here at Seoul, this is where everything's sort of coming together. So we brought on NetSuite for our ERP, MRP system, and that really is the hub, the link, financial, where everything comes together. We take reservations from the reservation system, bring that in, that merges with the bill of materials from engineering that we convert from an engineering BOM to a manufacturing BOM. And that's fed into our demand planning system that lines up all the orders, and that pushes out purchase orders and requests for quotes to vendors, so that material comes in just in time at the right time, based on configurations, and the MES system then executes that on the floor, pushing whatever the build is for that day, that however we're going to execute things. And it's triggering equipment. We do integrations with smart equipment on the factory floor to trigger that build, that configuration, whatever it is, and then collect data as well. So automated tools, that imagers, scanners, temperature sensors, whatever we want to control, that data comes into the MES system and is tracked by serial number and by vehicle VIN. So we know when a car or a vehicle leaves here, we know everything about it. So full traceability is really what we're shooting for, from not just the factory floor, but all the way back to engineering. What design decisions were made, what torque value was picked, did that get to the floor, is that recorded by serial number? And that's what we've been doing. We've done that in a simulated lab area. It's that floor plan you saw, which was the actual building, but we did it in a very compressed area, a small room, and we are running through all the material handling, material tracking, movement, exercising, integrations, simulating the factory as if it were ready, so that it is ready. And we proved that out. So the solar line was the first to get up and running. So we introduced MES system into that line, and it was pretty seamless. Like a day or two, and we were just process mapping, and it was already up and running because we had tested everything in a simulated environment. This was all sort of behind the scenes while the vehicles being designed.
So instead of waiting for production to begin, it's like you're preparing for battle. You guys are simulating the entire build of the vehicle. You're testing the system for stress and scale and seeing what breaks, fixing it, and just making sure that everything is ready to handle 40 vehicles a day.
Yeah, and we want to start obviously with launch editions and have commonality, but we're already prepared for variations. You can configure the vehicle, or we're planning for future state when you have multiple vehicles. Maybe things are running through the same line. Like we have to be prepared for that before it happens. So that's been the big effort for the last year or so.
it's very cool to see the vehicle being virtually built before there's ever anything on the manufacturing floor. I've had 8 startups, and to have all these tools at your disposal, I think we're in just a very unique time for startups to be able to scale more effectively. To be able to design it and then put that part into product life management, and then be able to have that in your enterprise resource planner, and then throw it over to your manufacturing execution system and actually have all that data tracked from beginning to end. It just makes for a whole different world, and understanding your cost, understanding the time to actually build that product, and in the end, understanding your profitability. So, I've had other companies where you're managing things on Excel spreadsheets, and then you actually start building them, and then they cost a lot more, and
Right.
they take a lot longer to build. And then, by the time you want to add a sophisticated system, it costs you hundreds of thousands of dollars and a long, long time to implement.
How do these Red Viking AGVs come into play versus like a regular assembly line?
These are material handling equipment, automation. So, the nice thing about it is, right, you can program these things, and you can get data from them. So you can trigger them to move to, where the stations are. You can get data on where stuff's at, and if you need to move something out of the line or back in. It's automating, instead of pushing a car around or carts or whatever. You're on the AGV, and that's where your factory automation comes in. And that's usually the start of it. At some point, you're on the wheels, and you can roll. But
So in a typical automotive assembly, if they have an issue with quality, they either have to stop the line or push the defective vehicle out and then to what they call the hospital and fix it later. But here, the AGVs can leave the line, and something could be sorted out or repaired, and then everything else behind it would just continue.
yeah, and those are probably very situational on what the issue is. Is it affected downstream? Is it just a single vehicle?
But it lets
You
us,
have options.
yes, and it also lets us move into virtually any building
Yeah.
to set up an assembly line, because we don't have things chiseled into the floor. We have these robotic carts that move the vehicle from station to station.
Yeah, I think the idea has always been sort of this transparent factory. It could almost like be there, it's not there. Everything's just kind of floating through and passing through. The AGVs just know kind of where to start and stop and land, and that's where people work. And then it moves to the next thing, and then that's where people work. And everything's tracked by serial numbers, so you know where that car is. Or vehicle. It's tied to the AGV. It's all integrated. That's our vision.
Very nice.
Yeah, before you can start simulating a factory, you have to know what equipment's going to be in that factory. So it's great that we have virtually all of the equipment quoted and almost sourced for our facility. You see on the list here, all these are the things that will fill our factory in terms of equipment. And the only thing that we're still working on is closing a contract on the battery assembly and module assembly parts of the factory.
Yeah, and I would add to that, Chris, it's not only selected and sourced, but it's also been awarded.
Yes.
So
yeah.
these companies have already been awarded the business.
And then Monroe knows what's equipment is in our facility, so they can work on their end for, takt time and cycle time analysis. And they've been a great resource and, kind of pointing us in the right direction. No, you want this kind of equipment, not this kind of equipment. We've seen facilities with this kind of equipment. It didn't work so good. So go to
We
this
have
vendor.
seen it.
And the vehicle, the parts that actually build the Aptera have been largely sourced. 92% of the value of our bill of materials has been sourced and awarded. Some of the things that are lagging, the body controls and some integration stuff, those point of use controllers and some of the wiring harness stuff, we're still waiting for quotes to come back. And then select a final vendor for them. So that's why they're lagging. But we don't have to pick them as quick as some of the harder items like the body structure and suspension. Those things have really long leads, 6-9 months in some cases. So you have to lock those down early. Some of the electronic components and connectors and stuff, you can get those within weeks. So we don't have to be as concerned about those. This is a list of all of our suppliers. There's a lot of them. The external, parts of the vehicle. Some of these are internal, but
Yeah, it's good to note on this. I mean, I think, I don't know, when we started 2 years ago, there were no suppliers on here.
Yeah.
We had maybe Alafe.
Yeah.
And over time, it's a ton of work that Pablo's team, the supply chain team, have done to go out. And right, a lot of these are down selected suppliers. I mean, there's so many suppliers that you go to, you talk to, audit, try and down select to get to this point. It's a lot of effort and networking. and making sure you find the right fit and who has capacity and throughput to get down to this. So there's a lot of lines, which is good. Orange lines are good, and we want lots of those. But we've come a long way. We didn't always have all these guys lined up. Same thing within interior. I mean, so many suppliers now lined up that we didn't have anything, a year or so ago. Just shows a lot of the progress that's been made up to this point.
Tier 1 suppliers that you'd expect to, provide parts to Toyota or Ford or, the traditional automotive supply chain, provides a lot of what's in our vehicle. Though we have a lot of uniqueness, there's a lot of just standard things that we need. This is kind of those suppliers on a bigger chart, but it's taken a lot of relationships to drive us towards production.
Yeah, I mean the tier ones, right? They have suppliers as well. There's a full supply chain even behind these guys that were, standing on the shoulders of giants here, trying to get a full vehicle completed. It requires leveraging a lot of these vendors who've built capabilities. We want off-the-shelf parts wherever we can, tailoring parts that we have to, and then we design ourselves what we have to. What there's nothing out in industry to go get. And then as well, the equipment suppliers that we have on the bottom there, right, just as important. There might be more equipment parts than vehicle parts. So, we have so much material handling equipment, assembly equipment, robotics, all these equipment vendors, just as important to get the line set up and integrate the product into production.
And aside from the suppliers, a lot of strategic relationships, from Crank helping us with our user interface software, Alafe co-developing our motors and initially building them in Slovenia, but then onshoring that production to the U.S. Eve with battery cells and Hinduja Tech with just a lot of other engineering resources. It adds a really deep bench to what we're doing. Maxion for the solar cells, and Roush for more engineering contracting, helping with the suspension, helping with some of the impact studies, some of the thermal stuff. Roush is very good at what they do, and they have a lot of great engineers to add to what we're doing. Yazaki is the largest wiring harness manufacturer. They're in half of every new vehicle sold. We are small fry to them, but they love solar mobility, and they've offered to help any way they can, and they really have pulled through. We have some other help with the supply chain in Asia with Chery. They're the largest vehicle exporter in China, and we've licensed 2 of their vehicle platforms and are using a lot of those parts. And obviously, CPC is a huge relationship, not just in the size of their presses, but in how to get this body structure put together. They've just been so welcoming to our idea for solar mobility and how we get this thing built, and they are just running towards production as fast as they can. And we have something very special to show you, something that not even everybody in the company has seen yet. We have actually started cutting production tools with CPC, and this tool right here is our first production body.
Can you tell what
tool.
it is?
Left-hand body side.
Mm-hmm. There you go. We've seen the data, so you're cheating. But this is just, it's extraordinary. It's a first huge step towards production. And, this block of steel is it's the size of a Toyota Prius.
I mean, all these blocks, they started their life in Germany about 6 months ago when we placed the order for them. So it's taken that long to, have them made. They have to get in the production queue, then they have to be shipped to Italy. You can't put many of them, I think only one on a truck just because of their size. And then to get them into the queue to start machining. And here it is, January, on schedule, and we're cutting tools for the 6 structural parts for the beam. So this is a massive milestone for us.
And the steel is just so pretty. This is this is a right-hand body side. Again, cheating from the data, but look at those steel chunks fly. And this is actually one of the cover panel parts, but very cool to see all of those things coming together.
And this isn't really also just an important part. This isn't parts coming in and out and going all over in Italy. This is CPC's own tool shop. They've helped us design the parts. They've designed the tooling. They're machining the tooling under their facility. then they'll be operating the tooling in their presses. So they're extremely vertically integrated, which gives us both control over quality and functionality and price.
Yeah, it's amazing to see these things come together. I love it when a plan comes together, type of thing. But it's been a long road thinking about how we build volume composites. How do we build 100,000 Aptera a year, not how do we build 100 or 1,000 or 2,000? And this is really the first steps to doing that. So now we're going to talk about how we actually push this manufacturing plan forward. We'll let Nick go. Thanks so much for
Thanks,
talking
guys.
us through some of the supply chain and MES. It's all amazing stuff, and it's great to hear it from the people themselves. Now we're going to talk about how you can help us get to production. We want to see Aptera on the road as quickly as possible, and you can help. Today, we're announcing the Aptera Accelerator Program. And this program opens up 2,000 reservation slots for the early launch edition vehicles. We're going to run this program through March 26th. We might extend it, but that seems like a reasonable amount of time for this program. And it's a minimum of a $10,000 investor. But everyone on this call is a previous investor. So for everyone on the call and previous investors, if you invest $10,000, we will also count the previous money you invested in this campaign. And we're all fighting for the coveted #1 Aptera Launch Edition reservation slot. We feel that's going to be very valuable. So, the person that invests the most money in this campaign will get Aptera reservation #1, and then the second most, Aptera 2, 3, 4, all the way through those 2,000 slots. And we think this will be a pretty cool way for people to get the first really valuable vehicles. Don't worry if you're a Paradigm Edition holder. If you are able to get one of these early Launch Edition reservation slots, we'll deliver your vehicle as a Launch Edition, Paradigm Edition, so you'll have an extra special vehicle. But if you want to invest, you have to go to invest.aptera.us. And if you want to see the leaderboard after you invest, see where you are in the stack of reservations, go to aptera.us/leaderboard, and you'll be able to see the progress on this campaign. How we're going to use this money, we think that this campaign can raise $20 to $50 million rather quickly, and that can really accelerate our path to production. It can buy us, laser welders for the battery line. It can buy us lamination equipment for the solar line. It can finish the beautiful steel tooling that you just saw at CPC, assembly jigs and assembly equipment for the line, and also, we've been selected for a very consequential grant, and it allows us to match that grant and start on that grant right away. We're also applying for a government loan, a very large loan package, which is supposed to make the nation more green and bring fresh technologies to transportation. It's perfect for us.
And we're talking with large institutional investors, with sovereign funds, and having very engaging conversations. But those deals take time to close.
And this campaign will help us, push towards production while we're completing those conversations, and bring those to conclusion sometime in the coming months. It really helps us on our launch strategy, and we realize we're giving up the first 2,000 reservation slots, and a lot of you have early reservations, and now you have to invest in this campaign to earn one of the top spots. But overall, if we get to production 3 to 6 months quicker, that means everybody receives their vehicle quicker. So even if you're after the 2,000th reservation slot, if we can get into production 3 or 6 months quicker, we will have built more than those 2,000 vehicles. So we think it's a plan that works for everyone. It accelerates our path to production. It puts more Aptera on the road. We want to see parking lots filled with solar mobility, grid independent mobility, mobility that makes your life easier, that costs less, that uses less material to create your transportation device. And with your help, we can do it. So we encourage you to go invest in this campaign and try to earn that top spot. And please tell your friends. If you have a friend that wants to be the first in their community with an Aptera, these first 2,000 slots are the way to do it. So we're humbled by your ongoing support. All of your investments have made everything you've seen today possible. It's been amazing that everyone has had just such positive words and kind gestures. Cheese and cookies on the table from people that have sent for holiday gifts. So we hope that our community can just keep marching forward and we can bring solar mobility to the masses quickly.
It's been a long road for us, but we still have a little ways to go. But with your help, we're going to get there.
Thanks, everyone. We greatly appreciate it.
Thank you.
Yeah. Do you want to take any questions from?
Yeah, do you
Do you guys want to take a few?
Yeah, we can take a couple questions. We'd be glad to.
make
Now I can clear my
questions
throat.
about the program?
Yeah, so probably maybe no technical questions this time, just
Okay.
questions about the program only.
Sure. Sarah's going to feed us some questions. We're happy to
Yeah,
answer.
just put them in the chat. I think that's easier.
In the chat?
Oh, we're not watching.
If you have questions, put them in the chat, and we're happy to
Or is it
answer.
for Q&A? Okay,
Let's see.
we're gonna ask questions.
A lot of people excited.
Awesome.
That's good section.
Let's see. Any financials? Are we sharing any more detailed financial information? Whoa. Okay, here, hold on. Sorry, there's lots of.
How much of this?
Sorry, they're trying to check the questions.
Let's see. Do you want to kind of explain how this money unlocks our path to production a little more?
Yeah, it's really about kicking off some of the long lead equipment and tooling.
Right.
There's a lot of big purchases that we need to make, and if we hold off on those purchases, it just delays the actual time and we can start production. So the brake system is something that we need to kick off. The CPC tools are pretty long lead. It takes CPC about 6 months to commission those tools. So they're cutting now. It's about 6 months before they start making parts out of those tools. But it really does unlock a lot of the initial spend that we have to make this 12-month production path happen. And it also really enables us. This grant is pretty significant.
Right. We still have to finalize the grant. We've been selected for the grant. It still has to be finalized with the state. But for us to begin receiving that, it's a matching. So it's a 60-40 match. We have to spend $1 and then we get back 40 cents, something like that. So we have to have the money to get the match.
Yeah.
Can you clarify just that it's a new $10,000 investment?
Yeah, for existing investors, it's a new $10,000 investment, and then we will count your previous investment. We know there's probably a lot of investors on this call that may be a heavy lift. We greatly appreciate your support, and if you can invest any in this campaign, whether it's $100 or $500, it really helps our mission towards solar mobility for all. But this program, we're really trying to get the average investment of those 2,000 reservation slots up. Because if the average investment in this campaign is $20,000, that's $40 million for our production efforts, and that gets us going. That gets us on the 12-month plan. So we hope that the top spots go for a lot. We hope that people are really competing for that
Someone
top
wants it.
spot, and it would be great if it was a million or more to get that top reservation slot, because that will be a very, very special vehicle. It will be the first production solar vehicle. And we think it'd be really valuable and something people will hopefully fight for.
Absolutely.
Great. Can you talk about IPO timing?
Yeah, if we're able to have a successful campaign here, and that helps us unlock the rest of our 12-month plan to get to production, we're looking to do an IPO just before we start production, because that's when we feel it's just the right time to kind of access the public markets. So hopefully, if it's a 12-month path to production, it's also a 12-month path to IPO. But there's a lot of factors there, and there's
Right.
a lot of ways that we could go public. We're considering public options now. That could help with some of our funding through the next year. So it could happen really soon, but our plan is that once we get into production, that should be about the right time to do an IPO.
We'd be in the strongest position then.
Yeah.
Can you talk about international expansion and how international customers can participate in this promotion?
Yeah, we have plans to build 8 assembly facilities across the world by 2028. We want to deliver 1 million Aptera across the world by 2033. So we have ambitious goals. We want to be everywhere. We want to be shipping to Europe and Australia and parts of Asia and the Netherlands. And we may have production facilities very close to those places. But if you're in Europe and want to support this campaign, you will have to take delivery of these first 2,000. All the launch edition vehicles will be delivered here in California. So if you're going to take delivery of your vehicle, you're either going to have to make arrangements to receive it in California, or buy a plane ticket and come and get a hug from the founders and get your personal delivery done here and learn how to use your Aptera while you're here in Southern California, and then figure out how to get your vehicle back to Europe.
But I think it's the other answer is also that it's going to be homologated for the North American market first.
Yes.
And then we'll have a schedule we can talk about publicly of what countries it'll be homologated in next. And that's going to be...
There's exemptions to get a few vehicles into almost any country.
Right.
But if we want to ship 10,000 vehicles to Europe, we'll have to be homologated for Europe. So in the beginning, with our current order base, shipping to Europe is not that big an issue. You can ship 1,000 vehicles to the UK tomorrow. But if you want to ship 10,000, then the regulators
Or
want you to have all
1,001.
paper. Yeah, or 1,001. So.
People are asking why we chose to do it this way and not like non-refundable deposits.
Yeah, we did consider non-refundable deposits, and that was kind of the first thing that was on the table. But in California, you cannot use deposit money for anything except the build of that product.
Right. California law is very clear. Deposits are deposits, and
Yeah.
they have to be held in escrow and able to be returned.
So once we get close to production, we'll take deposits, because that money will be put right towards your vehicle, buying the parts for your vehicle. But now, we can't use that money to buy tooling and equipment and pay to execute some of the ED&T that we need to like the braking system. We just can't use deposit money for our operations or any of these things to really get us into production.
It'd be great if we could, but it's in a lockbox. You can't touch it.
Yeah, we think that a lot of people would be fine with paying a significant deposit on their Aptera, and we could raise as much or maybe more than this current campaign, but we can't use that money. So this is the way that we're asking for you to support Aptera right now.
Cool. People asked, is Aptera going to be fine without auctioning off these reservations? How do these help accelerate the plan, basically?
We're confident that this plan will get us between $20 and $50 million of funding in short order. As I said, if the average investment in this campaign is $20,000, 20,000 times 2,000, that's $40 million. That's enough capital to kick this plan into action, and we're on a path 12 months to production. So that's what we hope will be the results from this campaign, and we hope that it will unlock, the ability for us to kick off all this tooling and do this grant work and apply for a government loan and work with equipment financiers to finance a lot of what we need to get into production, and all of that together delivers your beautiful Aptera to your driveway sooner rather than later.
Yeah, we've got active investment engagement. I mean, we've got lots of deals that we're working. Some are better than others, and we want to make sure we get the right deal for Aptera. So those are going to take a while to close, and if we can execute this program and raise $20 to $50 million, it lets us keep on the schedule, maybe even accelerate some things by spending the money today rather than a month or two from now.
Yeah, our community has been our number one asset, and we feel that we have a really strong following. Almost 1 million people following us now. We have the 15,000 investors, which you're a part of, and 40,000, almost 41,000 reservation holders for the Aptera. And within that community, we feel we have 2,000 people that would love to have one of these first reservation slots, and that will be tremendously impactful to the company. We'll continue raising bigger funding with some of these large investors and institutional and sovereign funds, and that will come. But we really just started that process towards the end of last year. We had been focused kind of on North America, and it's really Europe and India and Asia and the Middle East. That's where deals are happening.
You've seen us travel to the Middle East and Europe. We're going to Europe next week to meet with folks.
Great. What's the value of this investment? So what is the stock price of this investment?
The pre-money valuation is roughly $795 million for the company, and the stock price, the equity that you would be buying per share, is $10.50 a share.
Okay. Can you outline how the orders after the 2,000 will be prioritized?
So if you have a current reservation slot and your reservation slot is 657, then after we build these 2,000, you would still have your reservation slot. We'll still deliver according to the original reservation slots after this. But if you want one of the coveted first launch editions, then please invest in this campaign, support the early progress of the company and our path to production, and try to get number one.
Yeah, and how will those other orders be prioritized? Like location and...
Oh, yeah. Obviously, we want to deliver as many vehicles in Southern California first, and we have a rollout plan to the other states after that. But the easiest way for the launch edition is to deliver them here because they're close. If there's any issues, we can take care of them. And California is very easy to sell in. There's no restrictions for us in California. We're a California company. We're a registered motor vehicle manufacturer. We can deliver here tomorrow. We can sell the vehicles that are on the floor.
And we do have a state-by-state rollout plan. We just haven't shared that publicly yet, and that's something that Sarah and her team have been working on.
Yeah.
Great. And then how many days of production do we expect to take to make the first 2,000 vehicles?
Oh, that's a good question. We are not slowly stepping into production. We're not starting at 1 vehicle a day and then going to 2 vehicles a day and then going to 40 vehicles a day. We're going to 40 vehicles a day. There's some line prove out for that. And Pablo has said, it takes about 9 months to get the line rolling and then about 3 months of prove out. And then you're starting production.
Right.
So, when we're building at 40 vehicles a day, it's about 10,000 a year. Those first 2,000, I would have to do the calculation to do the amount of days, but it's just a couple months. Just a couple months worth of production gets you those 2,000 vehicles. So if we can accelerate the plan by 6 months, we will build far more than those 2,000 vehicles, and everyone will get their vehicle more quickly. So that's kind of the calculus in this plan, is that how do we get everyone their vehicle more quickly? We think these first 2,000 slots are very valuable, so let's accelerate the plan. If we can accelerate the plan by even 2 months, everyone will get their vehicle more quickly.
And launching at full rate is really what both Pablo and Sandy Monroe recommended. It's a disaster, they said, to kind of creep to production. You have to start out as close to max rate from the beginning to make sure everything works and to keep the mindset of the people, the system, that you're making 40 vehicles a day.
Yeah, if you have someone building 1 vehicle a day on the assembly line, you hire that person to build the equipment to build 1 a day, and then you tell them you got to build 40 a day, their head explodes. Like, this is not possible. I'm not going from 1 to 40 a day.
Right.
But hire the people, get the equipment, train the people to build 40 vehicles a day. And obviously there's some commissioning to be had and some kinks to work out. But plan for and capitalize for and hire for and train for building 40 vehicles a day.
That's right.
And then once you're good at building 40 vehicles a day, then just duplicate that with a second shift. So you can build 80 vehicles a day. And 80 vehicles a day gets you 20,000 vehicles a year out of this facility, which we think is just amazing progress in making transportation cleaner and greener for the planet.
Okay, great. I guess last question. We've talked about institutional investors. Some questions about how can the people on this call help with attracting institutional investment?
If you have friends in the institutional world or friends that are very wealthy, high net worth, or have a family office, we would love to talk with them. Share with them the story of solar mobility. Send them a link to one of our videos. That's how to really capture the imagination, seeing this thing in real life. This isn't a rendering. This isn't CAD. This isn't an idea. This isn't something that needs to be, proved out. This is real. We have real vehicles driving around powered by solar panels, and we have a real production intent design that's ready for manufacture. So, please share the story, share a video link, and hopefully they will see. I think that's what we're hoping for, is the right person to just see this and say, solar mobility, that's the future. If I'm investing in anything, I'm investing in the future, and that's it. Mobility that is grid independent, mobility that is the most efficient thing on the road, something that has a lot of utility. We think this is where institutional and large investors should be looking. But last summer was really tumultuous for the markets, and we basically blew out all the last half of the year because people just weren't considering investments. But we've seen that really turn around kind of towards the end of the year and this year. So hopefully people are excited for opportunity, and hopefully people have a lot of gunpowder, in reserve in terms of investment dollars, and they're ready to make a move for 2023. And it's exciting and an optimistic time that we can all together make the world a better place.
Yeah, all it took was one tyrant to turn off oil and gas to make people really think about energy. And what we're doing is we're taking this creative energy from the sun and turning it into free mobility. Who wouldn't want that?
Cool. When does it start? Someone asked.
Now.
Now.
Starts right now.
You can go to
I'm going to
invest.
go check the leaderboard.
You can go to
Yeah.
invest.aptera.us and you can invest now. The leaderboard probably won't be updated till tomorrow. So, give it today to run through, and then we'll take the data tonight and probably tomorrow have the leaderboard up. And we may only update the leaderboard once every 24 hours in the beginning, but we're working on an automated system. But please, if you can support us in this campaign, we're eternally grateful. You're helping solar mobility get to the masses, and it's been just an amazing journey so far. We can't thank you enough for your investment in our vision, and please support this campaign. Tell our story. Thank you so much.
Thank you very much.
Bye.